Before moving to the relationships representing with Venn diagrams, we'll come to know the actual definition of Venn diagram. What is Venn diagram? Venn diagram is nothing but a diagrammatical representation such as rectangle, circle, or oval shapes. They are represented, sets are represented in diagrams so that it will be easier to understand sets and sets relationships between two or more sets. Such type of diagrams are known as Venn diagrams. So here we are going to discuss about set relationships using Venn diagrams. Okay, we are going to use Venn diagrams to represent set relationships. So this first one is A union B, representing A union B as a Venn diagram. A union B, what is actually A union B? All the elements of set A and set B is known as A union B. Okay, so how we can represent in Venn diagrams? If there is a set A, this is the set A and this is a set B. So how we can represent this as A union B? What is A union B? All the elements of set A and all the elements of set B is A union B, and we write the shaded region is A union B. So all the elements of set A and set B is A union B, and this box is universal set. Okay, universal set is nothing but the set which has elements of all other sets. This is universal set. The rectangle universal set is represented in a rectangle. Universal set, what is universal set? The set which has all the elements of other sets and even its own elements. If look here, if A has 1, 2 and B has 3, 4 and universal set have an element 9, then is a set which has the elements of other sets and even its own elements. It even contains its own element and elements of other sets also. A intersection B is the intersection point. You remember this, when two sets overlap with each other, means they come in each other, then the intersection point, the area in which they are common, is known as A intersection B. A intersection B is all common elements of set A and set B is known as A intersection B. So here is an example. If A has elements 1, 2, 3, 4 and B have elements 2, 3, 5, 6, then we will represent this in Venn diagrams. What will represent A union B and A intersection B? Okay, how we can write A union B here in Venn diagram? So A union B, what is meant by A union B? A union B is all the elements of set A and set B. So this is set A and set B. And what are the elements of A? 1, 2. And the first you have to look at the common elements. What are the common elements in A and B? 2 and 3. We should write 2 and 3 in the intersection part because they are common. Okay, 2 and 3. And then the leftover elements of A are 1 and 4 and B are 5 and 6. Then first we'll write A intersection B, then we will continue. First we will write A union B, all the elements of A union B. How we can write A union B? Writing all the elements and writing common elements only once. We can write A union B like that. So what are all the elements of A union set A and set B? 1, 2, 3, 4. 2 and 3 are common, so we are writing it once. 6, 5, 6. Okay, and then A intersection B is nothing but the common elements of set A and set B. A intersection B is nothing but the common elements of set A and set B. What are the common elements? 2, and 3 are only the common elements. Can you see any other common element here in set A and set B? No, there is only 2. 2 is common, 3 is common, and they are not common. Leftover elements are not common, so only 2 and 3 are common here. So what is disjoint sets? If set A and set B are two sets, this is set A and set B, they are two sets. If there is no common element, look here, there is no common elements in set A and set B. They don't have any common elements in each other. There's 2. Is there any 2 in B? No. Is there any 4 in B? No. Is there any 6 in B? The sets which does not have any common elements between them is known, that kind of sets are said to be disjoint sets. So let me give you an example. We can find out A union B of the sets. What is set A? Set A is 2, 4, 6. And what is set B? Set B is 1, 3, 5. Then we will take out A union B. A union B of set A and set B. We can take out. So what is A union B? All the elements of set A and set B is A union B. So we'll write 2 first, all the elements of set B, and then all the elements of set A. Now we have to arrange it in ascending order. Then what is 1? The next is 2. The next is 3. The next is 4. The next is 5. The next is 6. So A union B is 1, 2, 3, 4, 5, 6. And now can we take out A intersection B? A intersection B is nothing but the common elements in set A and set B. Is there any common element in set A and set B? Look here, there is no common element. So the set is empty. The set is null set. The set does not have any element which is common. Then A intersection B is empty, that is null set. Okay, empty set or null set is similar. So here we can conclude that if A, B are disjoint sets, then their intersection is always null set. You can write this in closed brackets. Okay, if we find the difference of A minus B, what we are actually doing is we are taking set A and takeouting all the elements of set B from A. The common elements we are takeouting, the elements of B which are in A, we are takeouting those elements and we are keeping only A elements, that is this part. This part is A minus B. What is A minus B? A minus B must contain only the elements of A. We have to take out all the elements of B. Now I will even give an example on this. So look here. If there is a set A, for example, what are the elements in that? 1, 2, 3, 4, 5. Okay, and set B, what are the elements in that? 1, 3, 5. Now what we are doing? A minus B, finding the set A minus B. How we can get? We have to take out the elements of B from A. What are the elements of B? 1, 3 and 5. Okay, so we have to take out all the elements of B from A. So if we take out 1, 3 and 5, what will be left? First, how we will write is, we will write 1, 2, 3, A minus B. First we will represent it in set 1, 2, 3, 4, 5 minus 1, 3, 5. Then we will get A minus B is equals to, if we take out 1, 3, 5 from set A, then what will be left over? 2 and 4. Only the elements of A are left over. We have taken in all the elements of B from A. So in Venn diagrams, how we will represent this two sets, one is set A and one is set B. This is the intersection point where all the common elements will be. So this is set A and this is set B, and this rectangular box is universal set. So here, what are the elements of A? First we'll write common part so that we'll be not confused. So what are the common elements in set A and set B? 1, 3, 5. And what are the elements leaving the common elements of A? 2 and 4. Here set B only contains 1, 3, 5. One more example I will give so that you will be clear. A minus B. So if we do A minus B, then we'll take only 2 and 4. What will take? Only 2 and 4. Will not take 1, 3, 5. So what is A minus B? 2 and 4. Okay. We have find out the difference of A minus B. Now we will find out the difference of B minus A. If set A and set B are two sets, B minus A is a set which has elements of B but not of A, which will have elements of B but not the elements of A. We have to remove all the elements of A from B. That is this part. B is a set and we have to take out all the elements of A from B such that only B must be left. Okay. We denote it by B minus A. So what is B minus A here? B minus A is nothing but the elements. We have to take out all the elements of B. We have to take out all the elements of A from B so that B will be left. Okay. What will be left? B will be left. We have taken out the all elements of A such that B must only be left is B minus A. That is difference of these two sets, B minus A. So I will give you an example. What is the example? Let's take set A is equals to A, B, C, D, E, and set B is equals to A, E, I, O, U. Then first we will represent this A and B in Venn diagrams. So this will become easier to find out the difference A minus B. So B minus A. So if first we'll represent this in Venn diagram. So union, this is the set A and this is the set B. So first we'll write the common elements in middle so that we don't get any difficulty. So what are the common elements in set A and set B? A is there. Is B there? No. C there? No. D is not there. So A and E is common here in A and B. So we are writing common elements in intersection area. A and E are common, and leftover elements we will write in their respected areas. B, C, D, and B we have to write in B. So I, O, U. So here what we have to do, B minus A. What does B minus A refers to? We have to take out all the elements of, we are considering in B minus A only B. This we are concentrating on B. Here in B, what we have to do in B? We have to take out all the elements. This we have to take out, and we have to consider these elements A, I, O, U. This is difference of B minus A. Then what is B minus A here? B minus A is nothing but the leftover elements after taking all the elements of A from B. So what is left? I, O, U. B minus A is only the elements of B, not of A. So B minus A, we got it.